and now 1.7.4. What if you have an absolute value inequality? Now those are a tad bit different. Remember before when we had this problem, absolute value of x is equal to 3, you could put a -3 or a 3 in here and that would make this equation true. Well, you still have to consider the positive and the negative solutions when you have inequalities. The difference is greater than 0 means positive, less than 0 means negative. Okay? So let's put what we know about inequalities and absolute value equations together. Use all of the things we know about both of those. Well, first of all, you have to know that greater than means union. And you have to know that less than means intersection. So if you have greater than, you know you're going to have this symbol. And if you have intersection, you're going to have this symbol, or if you have less than. Okay, whenever you set up this inequality, you would write it down just like it is without the absolute value sign. So x is greater than 3. You would put an or, because this one is a union. And you write it down again, flip the sign, and make the right side negative. That's just how you would set it up. You would probably graph it and keep going from there. So let's look at intersection. You write it down just like it is. X is less than 3. This is an intersection, so you use and. Then you write it down, flip the inequality, and make the right sign negative. So x is greater than -3. So let's have a look at this and see how it actually works. This is a summary of all of the stuff that I just told you. Absolute value of x is greater than some number means this. So you write it down like it is, use or because it's greater than, and write it down again, flip the sign, make the right side negative. Ors usually have a split personality, so they're going in opposite directions. See how this one is also or, and it's going in opposite directions? Ands are almost always written this way, or graphed this way. You can write them like this. Okay? For this bottom one, you could actually write -k is less than or equal to x, which is less than or equal to k. Alright, so let's have a look at some problems, see how it works. Solve them as usual. So we'll have 3x plus 2 is less than 7. Since this is a less than, what does that mean? It means intersection. So we're going to have and 3x plus 2 is greater than -7. So solve each one. Since I only have a small amount of room, let me leave some steps out. We're going to subtract 2 from both sides. So we get 3x is less than 5. Divide by 3, so x is less than 5/3. You could graph that. You would be at 5/3 and pointing to the left. That would mean -infinity to 5/3, and it's a parenthesis, right? We don't really want to do that yet, though, because we have another half of this problem to do. So how about this one? We subtract 2 from both sides. We get 3x is greater than -9. Divide by 3, so x is greater than -3. Remember, this is an and. So what you want to do on your graph, figure out what they both mean. Well, -3 is down here, and 5/3 is up here, right? X is less than 5/3 looks like this. So what does x is greater than -3 look like? It looks like this. This means you want the intersection. You only want what they have in common. So what do they have in common? They have between -3 and 5/3 in common. So that would be your solution. -3 5/3 is the solution to this inequality. There we go, that's better. Okay, so how about number 2? On number 2, we need to get the absolute value part by itself first, so we need to divide both sides by -2. Since we divide it by a negative, we have to flip the inequality sign over. So absolute value of 4 minus x is greater than or equal to 2. So we set up our two cases. 4 minus x is greater than or equal to 2. 4 minus x is less than or equal to -2. What goes in the middle? This is a greater than, right here. Since that's a greater than, that means it's a union. Okay, subtract 4 from both sides. So we get -x is greater than or equal to -2. Divide both sides by -1, so we have to flip the sign. That's half of it. So the other side, subtract both sides by 4 and divide by -1, so we flip the sign. So on our number line, we know we have a 2 and a 6. X is less than or equal to 2, looks like this. And then x is greater than or equal to 6, looks like this. We want the union of those two sets. That just means we put them all together. So it's -infinity to positive 2, including the 2, union 6 to infinity. So this would be your solution set for number 2. Okay, last page. See if we can work on these. Okay, last page. Let's see if we can get these done. So we have the absolute value by itself. We go straight to working on it. Let's look at this first one before we do anything. We have absolute value of something greater than or equal to -3. When you take the absolute value of something, what kind of number do you get? You get a positive number, right? So no matter what is inside here, no matter what's inside there, aren't you always going to get a positive number? Okay, so aren't all positive numbers greater than any negative number? Well, that's just a little bit of analysis before we begin. You should know right now that this is all real numbers. However, what if you don't see that? You set it up just like we always do. 7x minus 9 greater than or equal to -3. 7x minus 9 less than or equal to 3. This is a greater than, which means it's a union. Add 9 to both sides, so 7x is greater than or equal to 6. Divide both sides by 7, so x is greater than or equal to 6/7. Over here we add 9 to both sides, 7x is less than or equal to 12. Divide by 7, x is less than or equal to 12/7. On the number line, 6/7 would be less than 12/7. So it says x is greater than or equal to 6/7. That goes this way. And then it says x is less than or equal to 12/7, which goes this way. And since this is a union, we want everything in both sets. Well, if we include everything in both sets, we include that entire number line. So your solution set is -infinity to infinity. Okay, so how about this one? The absolute value is not isolated, so we need to add 3 to both sides. Absolute value of x minus 6 is less than or equal to 1. Set up our two cases, x minus 6 less than or equal to 1, x minus 6 greater than or equal to negative 1. This is a less than. That means it's an intersection. So add 6 to both sides. X is less than or equal to 7. Add 6 to both sides. X is greater than or equal to 5. And remember, we have an intersection, so what do they look like? 5 comes before 7. X is greater than or equal to 5. X is less than or equal to 7. We want the intersection. We only want what's in common. What's in common would be between the 5 and the 7. So your solution set would actually look like that. From 5 to 7.